Hey guys, this is Mrs. Tran-Bloom again, recording 4.6 notes, operations with radicals. All right guys, so the first box, you guys have a couple of blank lines right there. Please write this down. One, combine like terms when you guys are, so addition or subtraction. One, combine like terms. You must have the same index and the same radicand. Remember, the index is this dude right here. So that's the index, okay? And then the radicand is what's under the radical. So that's what the radicand. Now, some problems will require you to simplify radicals before you combine like terms. Let's practice a couple here. Numbers 1 to 2, add or subtract. As you can see, number 1 said 7 square root of 12 plus square root of 27 minus 5 square root of 48. They all have the square root, so that is the same index, except they do not have the same radicand, so you do have to simplify that out. So let's simplify square root of 12. That's 4 times 3. Then square root of 27, that's really 9 times 3. Then square root of 48, as you can see. Now again, if the perfect square numbers don't come to your mind immediately, guys, start with an even number, like 2. 2 times what equals 48, right? So you can go to 24. Then you can go a little bit more. Well, 24 is really 2 times 12. Then 12 is really 2 times 6. And 6 is really 2 times 3. We call this prime factor tree. So all these numbers are all prime numbers here. And then you can write it in, and if they are pairs, you can take it out. As you can see, I have 1, 2, 2 pairs of 2's. So that means we can simplify that out. All right, so now what do we do with that? We're going to go 7 times square root of 4 is 2. Under, we have a radicand of 3. Square root of 9 is 3, a radicand of 3 again. Minus 5. Remember, we have 2 pairs of 2, so that means 2 times 2. And again, I have with one prime number, which is 3. And from here, let's multiply the outside number. I'm going to drop some of these down. And negative 5 times 2 times 2, that's going to be negative 20, rad 3. We are just now going to combine because look, the radicands are all the same and they're all square root. That means square root means the index is 2. So based on the rule, we said we are good. This is 17 rad 3. Take away 20 rad 3, so it's negative 3 rad 3. Box that up. Number 2, index is 3. Okay, so this is your index. This is your index. The radicands, 32 and 108, they are not identical. So right now you cannot add. So let's factor it out. 6, okay, third index of 32, I'm going to break it down as 2 times 16. And then break that down as 2 times 8. And you can, if right now you know the third root of 8 is 2, you can stop right here and just write like this. Third root of 2 times 2 times 8. Okay? If you don't, you can break 8 down to 2 times 2 times 2. Similarly, with what you do with 108. Again, it's an even number. You can start with 2 times 54. And then you can go, okay, well, 54 is an even number again. It's 2 times 27. You can break 27 down to 3 times 3 times 3. But if you do know that the third root, okay, of 27 is 3, then you can stop right here because that is a perfect cube. All right, so here I can't take out a 2 because I only have 2 2's. But I can simplify cube root of 8, which is really 2. I'm going to have 2 2's left inside, so I'm going to rewrite it as a 4. Similarly to over here, I can't take out or I cannot simplify 2 2's. I need 3 2's to take it out. So those 2 2 will stay as a 4. But cube root of 27 is going to be 3. Okay, so now this is 12 cube root of 4 plus 3 cube root of 4. Index is 3, radicand is 4. They are identical. So now we can combine them as 15 cube root of 4 and box it up. The next few examples, students, are on multiplying and dividing radicals, okay? Now, 4.6 is only on simple multiplication and division, but before we start the examples, let's write down some steps here. Step number 1, must have the same index. So, must have the same index. And remember, the index is this number right here, okay? Step number 2, multiply or divide coefficients. Multiply or divide coefficients. Remember, students, coefficients are the numbers that's on the outside, okay? Plural S. Numbers on the outside. Step number 3, multiply or divide the radicands. Okay, so multiply or divide the radicands. So radicands are the number that's on the inside. Okay, radicands, under the radical. Radicands, okay, numbers on the inside. Step number 4, you simplify when it is possible to do so. All right, let's try a few of these, okay? Example 3 to 4 is multiplying and 5 to 6 is divide. Remember, these are very simple ones. Later, we'll try more difficult ones. Okay, guys? Let's start with example 3. Fourth index of 3n times fourth root of 5n to the 7th. So the index, they're both 4, they are the same. So if they are the same, students, we can definitely multiply. Since the fourth index is in the problem, you have to copy it over. Then I'm going to write inside together, okay, like this. Then we are going to multiply 3 to 5 and the variables together, just like that. Then from here, as you can see, 3 times 5 is going to be 15. Now n times n to the 7th is really n to the 8th, because when you guys are multiplying numbers with the same bases, you add the exponent. Now we do have to simplify this. Now let's look at what's going on. You have n to the 8th. This is really meaning 8 n's, okay? So n times n, sorry, I'm gonna write this out for you. Just this one, so that way you have a better understanding. That's 5, 6, 7, 8, okay. Now if you have an index of 4, meaning that you need 4 identical items to get it out of the radical. I do have 4 identical items. Actually, I have 2 sets of 4s here. So that means I can take out an n, another n for the second set of 4. So now, under the radical, I only have a 15. So when you multiply what you took outside, here is what you guys end up with. Oops, this is an index of 4. Like that. And box that up. So final answer is n squared, fourth root of 15. Okay. Number 4. I have 6 square root of 5 times 4 square root of 10. The coefficients are 6 and 4. Put those together. The radicands are 5 and 10. Both have the square root, so that means the index is 2. They are identical. On the outside, that's 24. Now, on the inside, you have 5 and you have 10. I'm going to break that up to 5 times 2. I have a set of 5 here, and it's square root, so that means I can take that out. Okay? So now the radicand is just simply 2. So now on the outside, you have to go and simplify what 24 times 5 is. And so our final answer is 120 square root of 2, just like that. Dividing, same rules will apply. You have to check for index, which on number 5, they're both 3. So now, students, you can just rewrite them under one big ginormous radical. So now you're going to go, okay, 135 divided by 5, definitely workable. So that's going to be 27. And students, congratulations. Guess what? 27 is a perfect cube. So that's just going to be 3. Bam. Look at that. On number 6, we can rewrite it with a coefficient over one another. And then the 18 over 3, just like that. Well, 3 over 15, that's reducible to 1 over 5. Square root of 18 is really, you can reduce that, right? You're right, it's 6. So we can just multiply horizontally, just like that. So that's going to be rad 6 over 5, just like that. Now, if you wanted to, you can even write 1/5 times square root of 6. But that's kind of uglier, so normally we kind of don't prefer that. So we prefer this one right here. It's still correct, it's just not as pretty. So final answer is square root of 6 over 5. Example 7 and 8, guys, are just multiplying binomial with radicals, okay? So here are some guidelines. You first need to FOIL them as you would multiplying any two binomials. Then after that, you need to simplify your radicals when possible, and then you just add or subtract like terms, okay? So let's start. 7, the quantity of 3 plus square root of 2 times the quantity of square root of 10 plus square root of 5. Remember, when you are multiplying and adding and subtracting and dividing, all of the previous rules still need to apply. So let's FOIL. 3 times square root of 10 is 3 square root of 10. 3 times square root of 5 is 3 square root of 5. In the middle, square root of 2 times square root of 10. Oftentimes, guys, when you guys are multiplying, I'm just going to leave them just like that for now. And last, square root of 2 times square root of 5 is going to be just like that. Okay, now here's my reason why I'm leaving 2 times 10 and 2 times 5 under the square root. I'm going to get to that in just a little bit. So square root of 10, not much I can simplify with square root of 10. And square root of 5 can't do anything with that either. So those two are exactly the same. But before you guys get in a rush and multiply 2 times 10, it's a bigger number. So why multiply a bigger number when you can just try to see if you can simplify 10, right? And if you simplify 10, that's really 2 times 2 times 5. So now you know you can take out a 2. Now, 2 times 5, those are both prime numbers. We can't really do much. I'm going to leave those. But this one, we can simplify that out. So now I'm going to combine 1 square root of 10 with 3 square root of 10. So that's now 4 square root of 10 plus 3 rad 5. This is now 2 rad 5. Those can be combined. So 4 rad 10 plus 5 rad 5. And when you guys are adding, remember, the radicands got to be the same for you guys to combine. So since they are not, we can just box that up. All right, number 8, 5 times 5, 25. 5 times square root of 7 is 5 square root of 7. Negative rad 7 times 5 is negative 5 rad 7. Negative rad 7 times a positive rad 7, students, is negative rad 7 times 7 under that. Wow, these two are exactly the same. So we're going to cancel those. So currently we have 25. Well, we have rad 7 times another 7 and both of them under the rad. That means you can take that out, right? So now that's going to be 18. Now let's talk about these really quickly. You got 5 minus rad 7 times 5 plus rad 7. Those two binomials are related. Can you guys remember a word, a vocabulary word that we use to call binomials that are almost exactly the same except the sign in the middle are opposite of each other? So with a C, those are called conjugates, right? So 5 minus rad 7 and 5 plus rad 7. Those are conjugate pairs, okay? So what happens is, if you recognize that these are conjugate pair students, the middle terms will always cancel. So if you recognize a pair that are conjugates, then guess what? Just multiply the first two, multiply the last two, and then simplify, and then you should be done. So if you multiply the first two, you have 25. You multiply the last two, it's a negative rad 49, which is negative 7, and then you add or subtract, and you're done. So again, if you recognize that conjugate pairs, you can always just multiply the first and the last, okay? We just have a few more examples down here. It says here, rationalize the denominator, which aka make an equivalent expression with no radicals in the denominator. If you just have one term in the denominator called the monomial radical in the denominator, you multiply the denominator and the denominator, you multiply the numerator and the denominator by the radical expression that will make the radical cancel, and then you simplify. So let's go straight to number 9 with that guidelines. As you guys can see on example 9, there's only one term with a radical. Okay, so this is a monomial radical. As you can see right now, is a square root of 2. And a square root requires 2 terms to simplify the radical. So I'm going to go ahead and multiply the denominator by 1 more. What you multiply to the denominator, you multiply to the top. So currently we have 8 rad 2 on the top. On the bottom, we have 3, and we have rad 2 times rad 2, and most of you can recognize that just straight up 2. But if you don't, would you agree that we have 2 2's under the radical? So that's why, if you recognize that it's straight up 2 in the bottom, then you can just write a 2. Then from here, some of you would write that as a 6 and then simplify, but I would like to simplify first. I write 4 and 1 right there, so that would give me 4 rad 2 all over 3. Box that up. Okay guys, example 10 is very similar, except now we have an index of 3. So an index of 3 meaning that we need 3 identical items, okay, to get it out of the radical. So currently we have 2/5 under the big cube root. So I'm going to rewrite this as a cube root of 2 divided by a cube root of 5. Okay. Well, I do not need, or I do not want to have the radical on the bottom. With an index of 3, meaning that we need 3 identical numbers or items to simplify out of the radical. Currently I have 1 5. I'm going to need 2 more. So you can write 5 times 5, or you can write 5 squared, or you can write 25. However you choose to write that, that's really up to you. I'm going to right now stick with 5 times 5. In the denominator, we now have the third root of 3 5s, right? Oh, guess what? 3 5s with an index of 3, we can totally simplify. But what's on the top? On the top, we will write them together, 2 times 5 times 5. So now, on the numerator, we can't really simplify because we don't have 3 identical items. We have 2 times 5, which is 10. 10 times 5 is 50. So that's going to have to stay under the root. But on the bottom, we got 3 5s with an index of 3. So that is now out of the radical, and we box that up. One last question. Number 11 is 7 plus square root of 3 divided by 4 minus square root of 3. But that's a binomial on the denominator. So now let's go and read up. On the right side, it says binomial radical in the denominator. Multiply the numerator and denominator by the conjugate of the denominator, and then simplify. So let's kind of roll back up really quickly and talk about number 8, because we recognize those are conjugate pairs. So remember, when you have conjugate pairs, you guys can just simply multiply the first 2 terms and the last 2 terms, because the middle two terms will always cancel out, okay? So let's practice that. So the bottom, the conjugate pair of the bottom is going to be, the first is going to be the same, the last will be the same, and the sign in the middle will be the opposite. What you multiply to the denominator, you must multiply to the numerator. Again, the denominator, those are conjugate pairs, so we are just going to multiply the first two terms, which is 4 times 4, which is 16, and the last two terms, okay? Negative rad 3 times a positive rad 3 is a negative square root of 9, which some of you will see that that is straight up negative 3. On the top, students, those are not conjugates at all, so we have to FOIL those out slowly. 7 times 4 is 28. 7 times rad 3 is going to be 7 rad 3. Rad 3 times 4 is going to be 4 times radical 3. Radical 3 times radical 3 is going to be radical 9, which is I'm going to write straight up 3. So on the top, we can combine 20 and 3. That will give us 31. We can also combine 4 rad 3 and 7 rad 3, so that will give us 11 rad 3. On the denominator is 16 minus 3. Let's simplify that a little bit more. So that's 31 plus 11 square root of 3 all over 13. And we can't factor out anything on the top. On the bottom number, we can't do anything either. So guess what? That's our final answer without any radical. And students, that's it.